In this video, we are going to see the definition of the derivative function. Let's start with an example again, the function x squared. Here you see the graph of y is equal to x to the power of 2. Let's sketch the tangent. And for example, this point here, that will look like this. And this point here, it will look like this. And this point here, it will be a horizontal line. Here it will be like this. So this line is always the tangent. What we see is, we see that the tangent is changing the whole time. And also, the gradient of the tangent changes as we move along the curve. So here it's different than when you're here. And it's different when you're here. And it's different when you're here. So we can say that we see the gradient of the tangent changes as we move along the curve. We know how to find the gradient of the tangent that goes through a specific point. Let's say this point here. Let's say we have here A, just a specific point, and here we have f of A. In this point, this is the tangent, and the gradient of the tangent is equal to the limit as h approaches 0 of f of A plus h minus f of A divided by h. Okay, we can generalize that now. We can write a gradient function which gives the gradient of the tangent for any given value of x. So not only for this a here, but also for another value, another value, another value. So actually we can generalize this expression here, the limit here, for any random point on the graph, and that should give the following limit. So if I will write down, we can generalize that for any random point on the graph, and that will give the following expression. So instead of a, we can have any random point on the graph, so any random x value. So instead of a, we have to write x. So again, the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is the gradient function, which gives the gradient of the tangent for any given value of x. Okay, let's write that down again. So this here is the gradient of the tangent for any given value of x. So we call this a gradient function. So it's a gradient function which gives the gradient of the tangent for any given value of x. And in mathematics, we call this expression the derivative of x, the derivative of the function, sorry. So this expression is the derivative of the function. So you write it down like that.